started with the detailed drawing of drill jig. In that we have drawn the sectional front view and top view of the first part, that is the brace plate. Today we will be continuing with the drawing, that is the sectional front view and top view of the second part. So this is the second part. You can see here part number 2 has been located. So this is my second part. Today we will draw the sectional front view and top view of the second part, that is the stem. You can see from this diagram the second part is nothing but the stem, or we can say it as a locating pin peg, which is made up of mild steel and its quantity is 1. Before beginning with the sectional front view, we will first identify the dimensions of the second part, that is the locating peg. First, we will find the overall height of this second part, that is the locating peg. The overall height or the total height of the locating peg is equal to 133. You can see from here the dimension is given as 133 mm. So the total height from this line, that is the base of the locating peg, to the top of the locating peg. This is a top line representing the top of the locating peg. So the total height from here to here is equal to 133. Now the locating peg is divided into three cylindrical parts, or we can say three different parts. The first part from here to here is of height 50 mm. The second part from this point to this upper end, that is this corner, is equal to 51 mm. So the last part from here to here will be equal to the difference of 133 and 101, that is equal to 32 mm. So the height of the locating peg from this point to this point is equal to 50 mm. Then the height from here to here up to this point is equal to 51 mm. And the remaining height from this point to the top will be equal to 32 mm. Now we will find the diameters of the different cylindrical parts. So diameter of this part of the locating peg, that is the base, is equal to, you can see this diameter will be equal to 76. Since this locating peg is fitted inside the hole of the base plate, and the diameter of this hole, which is inside the base plate, is equal to 76. So the diameter of this lower part of the locating peg will be equal to 76. Now the diameter of the middle part from this line to this line is equal to 62. You can see the diameter of the middle part is given as 62 mm. So the bottom diameter is equal to 76. The diameter of the middle portion from here to here is equal to 62 mm, whereas the diameter of the top portion of the locating peg, that is from this line to this line, that is the diameter or dimension of this part, will be equal to 64. You can see the dimension here, it is given as 64 mm. So the diameter of this upper part of the locating peg from here to here is equal to 64 mm. So we have identified the height of the three different parts of the locating peg, as well as we have identified the diameters of the three different parts of the locating peg, that is the part number 2. In addition to these diameters and height, the locating peg is having an internal thread being performed inside it. You can see this stud, which is of major diameter 24. This is a stud which is inserted inside the locating peg, and it is having a major diameter of 24. So we can say that the locating peg will have a hole inside it, and threading is performed inside it with the major diameter of the thread being equal to 24. And since the major diameter is equal to 24, here we will assume the minor diameter as equal to 22 mm. So the locating peg will have a hole with threading inside it and with major diameter equal to 24. Now the total length of the threaded part or the hole from this line up till this line is equal to 64. You can see the total length of the hole inside the locating peg from the upper part, that is from this end to the top to the base, that is up till this line, is equal to 64 mm. Similarly, the locating peg is having here an internal threading performed inside it. This internal threading was provided to insert the cap screw, which is of major diameter 6 mm and its length is 50 mm. So first we will start the drawing of this locating peg. We will draw the outside boundary of the locating peg, and then we will show the internal threading on the upper side, as well as the internal threading for the cap screw on the lower side. So first we will start with a diagram. So for drawing the locating peg, the first line that has to be drawn is this line, that is this base line. Now this base line is of diameter 76 mm. So first we will draw a line at the base of length 76 mm. You can see now we'll draw a line of length 76 mm. So this is a line which will be of length 76 mm. So the diameter is given as 76. Now here we will give the dimension. So the dimension is equal to 76 mm. Now in the next step, what we will do, in the next step we will draw this vertical line which will be of length 50 mm. So now we have to draw from this left corner point a vertical line of length 50 mm, both on the left hand side as well as right hand side. So now we will draw from this point, we will draw a vertical line of length 50 mm on the left side. Similarly, we will draw a vertical line of length 50 mm on the right hand side. Now we can give a dimension. So the length of this line or the height of this line is equal to 50 mm. Similarly, the line drawn on the right hand side will be also of height 50 mm. So first we have drawn a straight line, that is the base diameter of length 76 mm. Then we have marked the height as 50 mm. Now in the next step, we have to draw this small line, this small horizontal line is from this point to this point. Now what will be the length of this small horizontal line? Now the diameter of the middle portion is equal to 62. You can see here 62 has been written. So the diameter of this middle portion from here to here is equal to 62, whereas the diameter of the bottom portion is equal to 76. So we will find a difference. So the difference of 76 and 62 will be equal to 14. So the difference is 14. Now we will divide this difference by 2. So we will get 7. So the length of this line will be equal to 7 mm. That is, we have to draw a line of length 7 mm on the left hand side as well as a line of length 7 mm on the right hand side. Now we will draw. So from this point, we will draw a line of length 7 mm. Again from this point, we will draw a line of length 7 mm on the right hand side. Now we can check the dimension. The dimension of this line is equal to 7. You can see here. Similarly, the dimension of this line will be equal to 7. We'll give the dimension. So the dimension of this line will be equal to 7 mm. Okay. Okay, this line is wrong. We'll draw it again. We have to draw a line of length 7 mm from here. So we'll draw a line of 7 mm length. Now we can give the dimension. So you can see this line is of length 7 mm. So after drawing this vertical line of length 50 mm, we have to draw a line, a horizontal line of length 7 mm on the left hand side as well as on the right hand side. Now I am deleting these dimensions. We can give it later on also. Now in the next step, we have to draw this vertical line, and you can see this vertical line. Now this vertical line will be of length 51 mm. So from this point, we have to draw a vertical line which will be of length 51 mm, both on left hand side as well as right hand side. So now we will draw a line from this point of height 51 mm. Similarly, we will draw again a line of height 51 mm from on the right hand side also. Now we can give a dimension. So this line from here to here is of height 51 mm. Similarly, the dimension of the line on the left hand side will be equal to 51 mm. So first we have drawn a vertical line of 50 mm, then we have drawn a line of height 51 mm. Now in the next part, the next step, we have to draw this vertical line. You see this vertical line, but before drawing this vertical line, we have to first mark the diameter of this upper part. Now the diameter of this upper part will be equal to 64 mm. The diameter of the middle part is equal to 62 mm, whereas the diameter of this upper part is equal to 64 mm. So now we will draw this line. So now this part we have already drawn. Now the dimension of this part is equal to 62. Now from this end you have to draw a line of 1 mm on the left hand side, and again from this point you have to draw a line of length 1 mm on the right hand side, so that we can draw the line of diameter 64 mm. Now I am deleting this dimension, we can give it later on. So from this point now you have to draw a line of length 1 mm on the left hand side, and again from the point, that is this point, you have to draw a line of length 1 mm on the right hand side. Now you can see this is the line of length 1 mm. So I will give the dimension here. You can see the dimension is what, 1 mm. So from this point you will draw a line of length 1 mm on the left hand side and line of length 1 mm on the right hand side. Again I will give the dimension here. So you can see the dimension is equal to 1 mm. So after drawing the line of length 51 mm, you have to draw a line of length 1 mm on the left hand side from this point, and from this point you have to draw a line of length 1 mm on the right hand side. So we have drawn line of length 1 mm on the left hand side and on right hand side. Now I am deleting this dimension, we can give it later on. Now from this point, that is this point, you have to draw a vertical line which will be of length 32 mm. Now you can see total height of the locating peg is equal to 133 mm. The total height of the peg is equal to 133 mm. The height of the portion from here to here is equal to 101 mm. From this point to this line base, the total height is equal to 101 mm. So the height of this upper part, which is of diameter 64 mm, this part which is of diameter 64 mm, will have a height of 32 mm. So now from this point we will draw a line of length 32 mm in vertically upward direction. So from this point you have to draw a line of length 32 mm on the upper side. Again from this point, that is this point, you have to draw a line of length 32 mm on the upper side. Now you can see if I give the dimension, the dimensions of this vertical line will be equal to 32 mm. You can see here the line is of length 32 mm, whereas the middle part was of length 51 mm. So we have given or drawn three vertical lines. First line was of height 50 mm, the second line from here to here is of height 51 mm, and the third line from this to the upper part is equal to of length 32 mm. Now we will join the top two upper points. So you can see, so we have joined the top upper 2 points. The diameter of this lower part is equal to 76. The diameter of this middle part is equal to 62. Whereas the diameter of this upper part will be equal to 64 mm. We can give dimension here. You can see, so the diameter of this upper part is equal to 64 mm. Whereas the total height of this locating peg will be equal to 133 mm. You can see the total height of this locating peg is equal to 133 mm. So it was given in question, the total height of the peg, that is from this line to this upper line, is equal to 133 mm. So we have drawn the vertical line of length 133 mm. Now I am deleting these dimensions, we can give it later on. Now in the next step we will draw the center line of this locating peg. So first we will draw a center line passing through the center of this locating peg. So you can see this is the midpoint. From the midpoint we will draw a vertical line that represents the center. So this is the center of the locating peg. From this midpoint I will draw a vertical line. So this is the center of the locating peg. Now this sharp corner has to be removed. You can see this is a sharp corner, so we have to provide a chamfering here. So we will provide some chamfer here to eliminate these sharp corners. So now we will provide chamfer. So note that you have to provide chamfer on both left hand side as well as on right hand side. So now we will provide a chamfer here. So now we will provide a chamfer to eliminate these sharp corners. So you can see we have eliminated the sharp corner by providing a chamfer. Similar chamfer has to be provided on the right hand side also. Now we will again provide a chamfer on the right hand side. So we will select the first line. So you can see we have provided chamfer on the right hand side also. So after drawing, you have to provide a chamfer of suitable length and angle on both on left hand side and on the right hand side. Now after providing chamfer, now next what we have to do, we will show the internal threading. That is internal threading on the upper part where this stud will get fitted, and the internal threading on the lower part where the cap screw will get inserted. So now we provide the hole, or we'll draw the hole to represent the internal threading. So now we'll check the diameters of the hole. So here the thread has a major diameter of 24. So we will assume the minor diameter as equal to 22, that is 24 minus 2. So the minor diameter will be equal to 22 mm, and the length of the hole with minor diameter as 22 mm will be equal to 64. You can see the total length from this line to this point, that is the hole which is to be drilled for making the minor diameter of the thread, will be of height 64 mm. This height, this is what 64 mm. So now we will first draw two lines which will be at a distance of 22 mm apart from each other to represent the minor diameter of the thread. So we will take 11 mm on the left hand side. Since the major diameter is equal to 24, we will assume the minor diameter as equal to 22. So we will take a distance of 11 mm on the left hand side, and then we will draw a vertical line which will be of length 64, since in the question it is given as 64. Again from this point we will draw a line towards left hand side at a distance of 11. You can see I have given a distance 11. Take a distance of 11 mm on the left hand side, and then draw a vertical line of length 64 mm or height 64 mm, and the total diameter of the line is equal to 22. And again we will draw a vertical line of length or height 64 mm. So you can see these two lines represents the minor diameter of the thread, and this will be equal to 22 mm. So the minor diameter of the thread is equal to 22 mm. Now at this end we have to draw two inclined line. Now this inclined line will be drawn at an angle of 30 degree. So now we will draw inclined lines at an angle of 30 degree. Now we will give the angle. Now this taper angle has to be 30 degree. So it is, we have to change this taper angle. The taper angle for the drill students, doing threading, first we have to drill a hole inside the locating peg, and for making a hole we use the drill tool, and the tip of the drill tool is in the form of a cone, and with the cone angle of the drill tool being as 120 degree. Total cone angle will be 120 degree. So we have to show the cone angle here with angle as 120 degree. So we will draw here the cone with 120 degree included angle. So from this point So this included angle of the cone will be equal to 120 degree. Now we can check the dimension. You can see here the total angle, included angle, is equal to 120 degree. So this taper angle of the drill tool will be equal to 120 degree. Now we will show the major diameter, or we can also show the angular distance. Here you can see this angle will be equal to 30 degree. So the angle between this horizontal line, the angle between this horizontal line and this inclined line will be equal to 30 degree. Again I am giving the dimension here, angular distance, angle. So you can see the angle between this horizontal line and this inclined line will be equal to 30 degree, because the total taper angle is equal to 120 degree. That is the angle between this line and this line, that is these two inclined line, will be equal to 120 degree. So if we find by calculation, we will get this angle as equal to 30 degree. So after completing this vertical line and drawing this horizontal line, you have to draw an inclined line at an angle of 30 degree from this point, and after getting this point, just join this point with this point by using a inclined line again. So we have shown the taper for the drill tool, which will be at an angle of 30 degree with respect to this horizontal line. Also, the length of this minor diameter will be equal to 64. So this hole which represents the, or this line which represents the minor diameter of the thread is of height 64 mm, whereas the diameter is equal to 22. Now we will show the major diameter of the thread. Now you can see from this figure, the major diameter is represented by these two outer lines. This outer line here on the left hand side and this outer line on the right hand side represents the major diameter. Now the major diameter length, that is the length of the hole which represents the major diameter, or the height of the hole which represents the major diameter, is not given. So we will assume a particular height of this major diameter line. So now for drawing the major diameter, from the center take a distance of 12 mm on the left. Since the major diameter is equal to, major diameter of the thread is equal to 24, we will take a distance of 12 mm on the left. So from the center take a distance of 12 mm on the left and then draw a vertical line. We will assume the here the length of the major diameter is 62, and then again we will draw a straight horizontal line with major diameter 24, and then we will draw a vertical line with length 62. So you can see here we have drawn this vertical line which represents the major diameter of the thread. Now the major diameter of the thread, that is the distance from this point to this point, will be equal to 24. So the major diameter of the thread is equal to 24, minor diameter is equal to 22. And here we have assumed the length of the major diameter, that is the length of the line which represents the major diameter of the thread, we have assumed here as 62 mm. So I will show the dimension here. So point is missing. We will take the dimension from this point till this point. So it is here 61.888 mm. We can assume here any suitable length. So we have taken here the length as 61.88 mm. So the major diameter, which is of dia 24, is of height 61.88 mm. You can assume here 62 mm also, whereas the minor diameter, or the line which represents the minor diameter of the thread, is of height 64, since it was given in the question, whereas this taper will be of 30 degree with respect to the horizontal. So we have shown the internal threading which is done for inserting the stud inside the locating peg. So this is the internal threading for locating the stud inside the locating peg. Now we will show the threading which is to be performed here for inserting the cap screw. Before drawing the internal threading, first we will mark the center. Now in the previous video lecture I have told that the center of the cap screw thread, the center of the hole in which the cap screw will be inserted, is assumed to be at a distance of 25 mm from this center line. So we have to first mark a distance of 25 mm from this center line. From this center line, we will take a distance of 25 mm on the right hand side, and then we will draw the center line. So this is the center line of the hole in which the cap screw will be inserted. And we will check the dimension. This dimension in the previous video I have told that we are assuming this dimension as 25 mm. So for drawing the hole in which internal threading will perform, to insert the cap screw, first we have to mark the center of the hole, and in the previous video lecture we have assumed the center at a distance of 25 mm from the center of the locating peg, since in the question it was not given. So here we have assumed at a distance of 25 mm. Now we will draw here the internal threading for inserting the cap screw. Now you can see this internal threading is having a major diameter as m6 mm. So the major diameter will be 6, whereas the minor diameter is to be assumed as equal to 6 minus 2, that is 4 mm. So we'll assume the major diameter as 6 mm and the minor diameter as 4 mm. Now we have to find the length of this threaded part. Now you can see the total length from this point to this line, that is from the base up till here, is equal to 44, whereas the height of this part, that is the head of the screw, will be equal to 10. So we can say the total distance from this line, that is from this line to here, is equal to 34, whereas the total height of the threaded part is equal to 50. You can see long 50. It means what? The total vertical height from this line to this line will be equal to 50, whereas we have found the total height from this line to this line as 34. Total distance is 44, so 44 minus 10 will be 34. So the total height from this line up till here is equal to 34. So this remaining distance will be equal to 50 minus 34, that is equal to 16 mm. So the height of the threading inside the locating peg will be equal to 50 minus 34, that is 16 mm. So now we will draw vertical lines of height 16 mm. Before that, from the center we will take a distance of, since the major diameter is equal to 6 mm, we will take a distance of 3 mm on the left hand side. Okay, first we will draw the minor diameter line. Major diameter is equal to 6, so minor diameter will be equal to 4 mm. So on the left we will take 2 mm, and the length or the height will be equal to 16 mm, and the diameter again will be equal to 4, and the height will be equal to 16 mm. So now we have drawn two vertical lines, or these lines represents the minor diameter of the thread. We can check the dimension. The total length is to be 16 mm. You can see the total height is equal to 16 mm. The diameter of this part will be equal to 4 mm, since it represents the minor diameter of the thread. So you can see we have to draw these two vertical lines which will represent the minor diameter of the thread, with diameter as 4 mm and height as 16 mm. Now I am relating these dimensions. Now we have to draw the taper, which will be the impression left by the drill tool after making the hole. So here we have to show the taper. Again, taper will be at an angle of 30 degree with respect to horizontal. The taper will be at an angle of 30 degree with respect to horizontal.